Welcome to a lesson with Dr. Powell. Let's talk a little bit about the notation that we often use for area functions, such as the one that we have for underneath the curve of sine of x. Only, let's be a little bit precise here. We're looking at bounds 0 up to a certain point x. Now, since this x is representing a particular point on this axis, we don't use the variable x to correspond to all the points on this axis since it's referring to just one. So notationally, we would use another letter, such as t, and call this a t-axis, so we can think of a t value of 0 and a t value of x. And then we're taking the area from 0 up until x, this x value, and that would be a of x. Okay, so the area depends on the bound x. Now, what do we know about a of x? Well, we know it's the antiderivative of, or it's a specific antiderivative of sine of x, where this curve is given by sine of x, except since it's a t-axis, we would normally write y is equal to sine t. But we think of a of x as being an antiderivative of sine. Of course, when we plug in x for t. Okay, so notationally, this is what we're going to do. We're going to think of a of x as being an antiderivative. So we're going to borrow the antiderivative notation or indefinite integral notation right here with respect to of sine t. But it's going to be, with these specific values, we're finding area between from 0 up until x. We're going to append them right here, 0x. So if you throw off the x and 0, then we get the indefinite integral. And but that helps us remember that we're taking the antiderivative. The 0x helps us remember that we're looking for a specific antiderivative. So we get this notation, a of x is equal to, and we read this as the integral from 0 to x of sine t dt. This is called, if you will, this notation is called definite integral notation. Indefinite would be a specific, or an indefinite would be a general antiderivative, but here we've actually come up with a specific antiderivative with x being plugged into it. So we end up getting this notation. Likewise, if we were to have an area function under another curve, suppose we have something like, I'll make that a little steeper there. Something like this, maybe say this function is y equals t, maybe t cubed plus 1 or something like that. Then, and suppose we want to start all the way back at maybe like, let's do -2. Then we're going to be looking at a net area function up until a point x. So this area function, we'd use this notation. A of x is equal to the definite integral. And we say from 0, well, actually, it's not 0 this time. It's -2, because that's where we're starting from. -2 up until x. And then we put in the function t cubed plus 1 dt. So this is another way of writing this out. Again, we use a different letter here than here because this represents something that we're plugging in to the antiderivative, as well as the function itself on the curve. Thanks for watching.